Hi, good morning to one and all. Myself A. Ramanjnelu. Today I am going to explain how to solve and how to calculate the shear force and bending moment diagrams for overhanging beams subjected to point loads. Okay, up to now we discussed for cantilever and simply supported beam. From today's session, I am going to explain how to draw shear force and bending moment diagrams for overhang beams subject to point loads and UDL loads and combination. Okay. First of all, read the given problem. Here the problem given that a beam of length 12 meters is simply supported at two supports which are 8 meters apart with an overhanging of 2 meters on each side as shown in figure. Okay, the beam carries a concentrated load of 1000 newtons at each end. Okay, at each end. Draw the shear force and bending moment diagrams for the given beam. Okay, it is the given beam. Here, this beam is subjected to 2-point loads. The 2-point loads are acting at both ends, that is left and right end of the beam, of the overhang beam. Here, it is overhang beam, so that beyond the supports, that is left and right side, having some distance, this type of beam is known as overhang beams. For simply supported beam, after the support, there is no gap or there is no extension, so that it is called simply supported beam. For overhang beams, suppose either one or both sides having some extension part, that extension part is known as overhang part, so that it is known as overhang portion. Sometimes the beam having only one side overhang portion, sometimes both sides. Okay, in some cases both left and right side having equal distance, in some cases unequal distance. Okay, all these types of beams is known as overhang beams. Okay, it is about overhang beam. Now I am going to solve the shear force and bending moment values by calculating the shear force and bending moment values. By plotting the values on this diagram, we will get the shear force and bending moment diagrams. Okay, before going to this, we need to calculate reaction forces at point A and B. Okay, it is the point A and it is the point B, so that we need to calculate reaction forces RA and RB. Where the supports is there, at that point some reaction forces will be developed, so we need to calculate that reaction forces. Okay, we know that from bending moment equation. Okay, that is RA plus RB. Now I am calculating the reaction forces. We know that RA plus RB is equals to total load on the beam. Here total load on the beam is 2000 newtons. 1000 plus 1000, that equals to 2000 newtons. Okay, I am considering this equation as 1. Now I am taking moments about A and equating is equals to 0, equating to 0 for calculating the reaction forces RA and RB. Okay, that means I am considering the taking moments about A, so that we need to consider right side forces, right side moments, that is having two forces, that is one point load and one reaction force. First I am calculating the 1000 newtons, that it is acting clockwise, so that I am taking it as negative, that is minus 1000 into distance from this load to this point A is 8 plus 2, so that total 10. Next, here acting reaction forces. This reaction force is acting in anti-clockwise direction, so that it can be taken as positive, that is RP into distance from this point to this point is 8 meters, so that RB into 8. Load into distance is known as moment. Next, right side of forces, only two forces. Left side of the support having one force, that is 1000 newtons. It is acting anti-clockwise, so that it can be taken as negative, because left side the signs will be changed, that is minus of 1000. Sorry, plus no, this plus 1000 into 2. Okay, generally it is acting anti-clockwise. Anti-clockwise generally we taken as positive for left side, so that what happen, it will be reverse, so that anti-clockwise left side is positive into 2. Distance from this load to this load is 2 and equating to 0. Okay, so that RB into 8 is equals to total load on the beam is 10,000 minus 2,000, that equals to 8,000, that equals to RB is equals to 1000 newtons. It is the value of RA. Substitute RB value in equation 1, will get RA plus 1000 is equals to 2000. Therefore, RA is equals to 1000 newtons. Okay, it is the value of RA. Now we calculated RA and RB. RA is 1000 and RB is 1000 newtons. Okay, now we calculated reaction forces. Next we need to calculate shear force values. Shear force values. Shear force we need to calculate at every point, that is point D, B, A and C. I am coming from point D. At point D, here there is load acting, so that we need to consider before and after load. Shear force at point D, before load the value is 0. Shear force at point D, after load means we need to consider this point load, so that the point load is acting downward, so that I am taking downward forces are positive, upward forces are negative during the calculation of shear force. It is the sign convention. Okay, my plus 1000 newtons. Okay, next shear force at point B. At point B, acting reaction force, so that we need to calculate before and after. Before load means right side of point B having one point load, so that the point load is 1000, it is positive. Next, shear force at point B after load, that equals to after load means we need to consider reaction force RB, that is 1000 minus of, because it is acting upward, so that it is taken as minus, that equals to 0. Shear force at point B is 0. Next, similarly we need to calculate shear force at point C. Shear force, at point M. At point A. At point A is acting reaction force, so that we need to calculate before and after load. Right side of point A having two forces, that is 1000 minus 1000, that equals to 0. Next, shear force at point A after load. After load means we need to consider this reaction forces also, so the total 1000, this downward positive, next upward minus 1000. Next, here also having upward force, so that we need to give minus of 1000. Total value is minus 1000 newtons. Okay, next we need to calculate shear force at point C. Shear force at point C acting one applied load, so that we need to calculate before and after load similarly. Okay, shear force at point C. At point C, before load, that equals, we need to consider right side force. Right side force acting one applied force and two reaction force, so that downward force is positive, and RB acting upward, so that it is minus 1000, and at point A, RA is reaction force is applying upward, so that it is taken as minus 1000. Okay, total value is minus 1000 newtons. Okay, similarly we need to calculate shear force at point C after considering the applied load. That means we need to consider all the forces. 1000 minus 1000 minus 1000 plus, at point C the applied load is acting downward, so that it will taken as positive. Final value is 0. Okay, shear force at point C is 0. At point C before load minus 1000, at point A after load minus 1000, at point A before load 0, at point B before load 0, next at point D, and point before load and after load. Before load is 0 and after load is 1000. Okay, by using these values you need to draw the shear force diagram. Shear force diagram. Okay, draw the straight lines. Okay, from this point need to draw at point A, B, C, D. Okay, draw the baseline. Okay, give the points. This one is A, B, C, D. Okay, next at point D, before load is 0. Before load is 0. Okay, next at point D, after load is 1000. After load is 1000. Next shear force at point B, before load is 1000 newtons. This is 1000. Next shear force at point B after load is 0, so that the curve is come to here. Next shear force at point A before load is 0. Next shear force at point A after load minus 1000. Next shear force at point C before load is minus 1000. Shear force at point C after load is 0. Okay, like this we need to draw shear force diagram. Here the values at point B and D are positive shear force, so that positive values, so that the shear force diagram is come above the baseline. At point from A to C, the shear force value is negative, so that it is comes, the diagram come under the baseline, below the baseline, so that it is the shear force diagram for given overhang beam subjected to point loads. Okay, at this point the shear force is 1000 newtons. At this point the shear force is 1000. Okay, like this we need to draw the shear force diagram for the given beam. Next we need to calculate bending moment. Next we need to calculate bending moment value. Here we need to calculate bending moment at point D, B, A and C. I am calculating first bending moment at point D. at point D there is having some shear force, but the distance from this load to this point is 0, so that the bending moment at point D is definitely 0. Next, bending moment at point B. At point B, right side of point B having one shear force, it is acting at a distance of 2 meters from this load. The load is 1000 newtons. The 1000 newtons is acting clockwise, so that it is taken as negative minus of 1000 into distance from this load to this point is 2. Okay, so that the value is minus 2000 Newton meter. Here the load is in terms of newtons and distance is meters, so that the unit for bending moment is Newton meter. Next, bending moment at point A. After B, next point is B. The right side of point B having two forces, one is applied load and one is reaction force. The applied load is 1000, is acting clockwise, so that it is taken as minus 1000. Distance from this load to this point is 10. Okay. Next, at point B, the reaction force RB, it is acting anti-clockwise. Anti-clockwise, that is 1000 newtons, so that it is positive. The distance from this point to this point is 8. Okay, so that the value is minus 2000 Newton meter. Okay, bending moment at point A is minus 2000 Newton meter. Next, bending moment at point C. At point C, we need to consider right side forces. That is, right side having one point load and two reaction force. The first point load is minus 1000. Distance from this point to this point is 12 meters, so that minus 1000 into 12. Next, the reaction force RB is acting anti-clockwise, so that it is taken as positive. The value is 1000. The distance from point B to point C is 10. Okay, into 10. Next, from at point A, acting reaction force 1000 is acting anti-clockwise, so that it is taken as positive. This point to this point distance is 2, so that load value is 1000. Distance is 2. Point A to C is 2, so that the final value is 0. Bending moment at point C is 0. Okay, by using these values, we need to draw the shear force diagram. For this, we need to draw baseline. Draw the baseline. Okay. Next, give the points A, B, C, D. At point D, the shear force bending moment value is 0. Next, at point B, the bending moment is minus 2000. Next, at point A, bending moment is minus 2000. Next, bending moment at point C is 0. Here, because at point A and B, A to B, there is no shear force, so that the bending moment is constant. Okay, that is the maximum bending moment at point A and B. Okay, because where the shear force is 0, at that point the bending moment is maximum. Okay. Okay, it is the shear force bending moment diagram. The values are negative because it is hogging type. It is the beam. Okay, when the load applied, it will deform like this shape. It is the concave is above the neutral surface. Sorry, concave, and convex is below the neutral, so that it is hogging. Okay. It is the bending moment diagram. And this one is baseline, and this one is straight line, and this one is straight line, and this one is horizontal line, because from A to B there is no load. from B to D having one shear force, one point load, and C to A having one point load. Okay. Okay. It is the shear force and bending moment diagram for overhang beams subjected to point loads. Okay. Thanks for watching. First is the given problem. First we need to calculate reaction force. Based on that we need to calculate shear force. By using that shear force values we need to draw the shear force diagram. Next we need to calculate bending moment values. By using these values we need to draw the bending moment diagram. Okay.